sit and read.
So today you're going to notice the title of today's section is Arithmetic Sequences as Linear Functions. So this is something that you probably haven't seen before. Or if you've seen it, okay, you might not have known that it was an arithmetic sequence. Because when you were younger, you probably did stuff like this in elementary school, but you never knew that it was titled a sequence, or let alone an arithmetic sequence. So first of all, let's define what a sequence is. Okay. A sequence is a set of numbers called terms. And so we number those terms. We say like the first term, the second term, the third term, the fifth term, the 100th term. And then today we're going to talk about something known as an arithmetic sequence. Now we have other types of sequences. We have a geometric sequence, and we have sequences that are neither arithmetic nor geometric. But for today, we're just going to focus on arithmetic. An arithmetic sequence is defined as being a sequence in which the difference between successive terms is the same. Now that might not make a whole lot of sense until we look at an example. So if it's not real clear what an arithmetic sequence is, that's okay, because when we get down to the example, I think you'll understand a little better. And so in an arithmetic sequence, we have what is known as a common difference. That common difference is abbreviated as a D. And basically, all that means is the difference between terms. So you're going to notice some examples below. We have 3, 5, 7, 9. That is an arithmetic sequence. And so in looking at that arithmetic sequence, I want somebody to tell me, what do you think the next term after 9 would be? 11. So what are you doing to every term?
Adding 2.
You're adding 2. So 2 would be considered the common difference. So that is an arithmetic sequence because on every term, I'm adding 2. Now for this to be an arithmetic sequence, you have to add 2 every time to this sequence. You can't add 2 here and then add 3 and then add 4. Okay. So let's look at the next one. 2, 0, negative 2, negative 4. What would the next term be here? Negative 6. What are you doing every time there? Subtracting 2. So if I start by subtracting 2 here, that means on every term after that, I have to subtract 2. So this number here has to be the same with every term. So let's go ahead. Oops, skipped one. Let's go ahead and go back. This asks, is this an arithmetic sequence? So this is how you check. Okay, what do you do from 9 to get 6? You subtract 3. What do you do to 6 to get 3? Subtract 3. You need to check all of them. So with that in mind, I want you to tell me, oh my gosh, we're skipping today. There we go. Is that an arithmetic sequence? Yes, just a second. For some reason it's kind of, there we go. All right.
Ooh, I think we got it
I know we're having trouble. I'll just leave it up there. Is that an arithmetic sequence? Yes or no? No. Okay, so let's go ahead and look at why is that not an arithmetic sequence?
It subtracts 2, then it subtracts 1.
Right. If you check here, I subtract 2 here. From 16 to 15, I subtract 1. 15 to 13, I subtract 2. Remember, in order for it to be an arithmetic sequence, all of those subtractions need to be the exact same. All right, let's look at this one. Is that an arithmetic sequence?
No.
What is up with that?
You could just say yes and then it'll go back.
We've never had that trouble before. There we go.
There you go.
Did it do it again?
Yes, hit yes.
We'll just go again. I'll try it again. My goodness. There we go. Let's try that now.
It's always when you're looking.
Isn't that odd? We've never had that trouble at all. And that is an arithmetic sequence. What is the common difference on that one?
It goes 5.
Add 5 every time. Good job. All right, so now, of course.
Oh.
Oh, look at that. All righty. This one you might not be able to look.
Just stare at it, and then it won't do it.
you watch it.
All right, so there we go. Must be playing a Halloween trick on me. Okay, so now this one's probably going to be one that you're not going to be able to look at. You might have to do some work and write down some numbers.
Give me a sec.
Let's see how you did on this one. Ooh, this one wasn't quite as obvious, and you can see from our results it wasn't. Now, real quick, this one was kind of tricky because, believe it or not, the first three do fall into play. They work. It's the last one that doesn't work. Because if I write these all in terms of eighths or sixteenths, let's write 1/2 in terms of eighths. That's 4/8, right?
Yeah.
Then you have 5/8. What is 3/4 in terms of eighths? 6/8. And so if you notice the pattern, really what should be the next term? 7/8. You're adding an eighth here. It's not. It's 13/16. Okay? And so as a result, this is not an arithmetic sequence. So you do have to check every one. Okay? So find the next three terms of the arithmetic sequence. So let's look at that one. We have 15, 9, 3, -3. So what would be the next term after -3? Yeah, go ahead. -9. Good. What would be after -9? Negative
15.
15, and then negative
21.
21. Now, for those of you that haven't picked up on it, what are we actually doing every time? You're subtracting 6, or you're adding a -6. Okay, so we're taking -3 plus -6, which is -9. Add another -6, add another -6. Now on this next one, what I did, instead of finding the next three, well, okay, we'll see if this works. Okay, there we go. Finally got to move that out of the way. Okay, find the next term in the sequence. Okay, so I just want you to find the next term, not necessarily the next three.
Bless you, Eric.
Thank you, Brad. He's blessed.
All right, 14 is the answer, believe it or not. For some reason, that must have not came through. Man, this is being tricky today. So the answer is, in fact, 14. What are you doing every time? Adding 4. Good job. Okay, next one. Ooh, that's a tricky one, isn't it?
Of course.
There we go. Finally got that one out of the way. Okay, let's see how you did. Okay, we're getting tricks played on us. It actually is 0.2 as our answer. So 0.2 would be correct, so the only one that we need to look at is the 1.4. Now what we're doing here is doing what on every term?
Subtracting 1.2.
Subtracting 1.2.
Yeah, 0.2.
And so if I subtract 1.2 every time, I end up getting 0.2. Okay, because 1.4 minus 1.2 is that. Okay, so now what we're going to do is we're actually going to write equations. This is something you need to get down. Chances are you're not going to be able to remember this, so you need to write this down somewhere. Notes would be preferable. Now this is an equation for the nth term. So say, for example, I wanted to know the 50th term or the 100th term. That is the equation. Now we're going to go through and kind of tell you what each of these values means. A sub n, that is the nth term. This is also the term you try to find pretty much, okay? So like if that would be the 50th term, if you would want the 50th term, that would be A sub 50. That's a subscript. So when I say sub, that's just a shortcut for subscript. So A sub 50. If you wanted the 100th term, what would it be? A sub 100. Okay? And so then now, A sub 1, that's the first term. That's what that 1 tells you, that that's the first term in the sequence. Okay? That's always the first term that's listed. N is the term you're trying to find. So if I had A sub 50, what would N be?
50.
50. Those numbers always match. Okay? And then D is going to be your common difference. Now you're probably wondering, why on earth would you need a formula like this? Okay? Think about it. Do you want to write out 100 terms in a sequence?
No.
Probably not. So this is going to be a shortcut way. Okay? So let's go ahead and look at an example. Write an equation for the nth term of the arithmetic sequence. So a few things we need to know. We need to know the first term. Do we know the first term? Negative 12, good. Okay, next thing we need to know is we need to know the difference between terms. So how you find the difference between terms is we find out what we do from term to term. You add 4, very good. Okay, so here's our formula. So all we're going to do is we're going to write in what we know. First of all, the formula, we're writing it for this. Okay, so we're just going to leave that alone on these problems. What am I going to put now?
12.
Negative 12. Yep, good. Negative 12. I'm going to leave n alone. And what is d, did you tell me? 4. Yep, plus 4. Same thing. Okay. Now all we need to do is we just need to simplify this down because notice I've got a 4 outside of a parentheses. What can you do there? Distribute. Nice job. So I end up getting negative 12 plus
4 minus 1.
Minus 4. And last but not least, I need to go ahead and add like terms if I can. And notice I do have 2 like terms, and what are they? Negative 12 and negative 4. Okay, now what I'm going to do is I'm going to go ahead and write the 4n first because remember that's kind of the approved way. We always write the variables first. And then what's going to be my last term?
8.
How about
It's gonna be
minus
negative.
16? Same thing.
I
So,
thought you did
negative 12 plus negative 4.
yeah, negative 12 plus negative 4 is negative 16. You could
It
write
is
it
not.
plus negative 16 or minus 16. It's the same thing. Now, just for kicks, let's just say we wanted to find the 50th term. Okay? So, do we want to keep writing out 4, 8, 12, 16, 20? No, because that's going to take us a while. So, what would be a way that I could find the 50th term?
A with a sub
50. Any
Equals-
ideas?
equals negative.
Ah, put 50 in for n. So if you wanted to find the 50th term, I'm going to put 50 right here. So I'm going to take 4 times 50 and then do what? Subtract 16. Very good. So 4 times 50 minus 16 is what?
184.
184. So that's my 50th term. Now if I wanted to find the 100th term, what would you do?
Put in 50.
Put in 100
100.
for n. Okay? So real quick, I want you to find for me the 100th term. Okay? I want you to find for me the 100th term. I want you to find for me the 100th term. let's see what we all had. 384. Nice job. Okay, so 384. Let's review again how we found that. Okay, how we can find 384 is we're just going to plug 100 in for n down here. So I've got 4 times 100, which is 400, and then subtract 16. Okay, write an equation for the nth term of the arithmetic sequence. So I'm going to start you on this, and then you're going to finish it for me. So our formula, a sub n equals a sub 1 plus n minus 1 times d. What is a sub 1? 3. Good. What is d?
Subtract 13.
D is negative 13. So what I want you to do is go ahead and write the formula in simplest terms. Okay? Write the formula in simplest terms.
And n is the, what we're trying to find for the
Yep, I want you to simplify it down if you can. Well, you can pick up one of the colors. Is it? That's not what you had written down.
No, it's not. I don't know what I've written down.
Nice. There you go. Good job. So here you go, folks. This is actually a very, very good way to solve this, okay? So we've got negative 13 for D, okay? Perfect steps. Yeah.
Could you have distributed the 3 and made it 3n minus 3?
Because you can't, because this is a plus sign. So you can't bring the 3 inside. So if you look at that, that is where we're at. Now what I want you to do, okay, I want you to find for me the 20th term using that. So if you didn't have that formula, this is the one you want to use because this is the correct one. I want you to find the 20th term for me. see how you did. Okay, so the answer is negative 244. Good job. Okay, so now let's review again. How can I find the 20th term? You plug 20 in for n, right. So all we needed to do here is take negative 13 times 20 and then add 16. Questions? Okay, so here we go. Your turn now. Write an equation for the nth term of the arithmetic sequence. Now this is a little different. Yeah, no, perfect.
Try it, it doesn't work. Here, let me see that.
All right, Joe's going ahead and writing up the solution, so you're going to want to go ahead and check.
Joe, Joe, go, 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 Joe, go, go. Wait, Joe, wait. Hey, hey, Mom.
You can't encourage.
Because you're mad.
You're making great.
Where'd you get that?
You know that, right?
Did you get it?
Well, you make a great one. He'd watch the football games on Saturday, and he would tell kids what to do.
My mom does.
I have homework.
I was late.
Okay, you know how,
Nice job. There you go. There's your formula. Should be 0.5n minus 1.5. So, follow up. I want you to find for me the 10th term. Find the 10th term.
Oh, crap.
Anyway, can we get to do that
Is
stuff?
that like your ultimate scratch move?
Oh, yeah.
We're having.
Okay, hang on.
Come on, Aaron.
Clay, shut up. I have no idea.
That's an excuse, right?
We'll know which one's mine.
Okay, so let's see what y'all did. 3.5, nice job.
Oh,
Okay,
we don't
so
know which
now-
one's mine.
To find in 10th term, remember again, what you're gonna do is you're gonna go ahead and plug in 10
Oh,
for
I
n.
forgot to put 0.5.
So 0.5 times 10 is 5, minus 1.5 is 3.5. Okay, so there you go. Page 193, numbers 8 through 21 for Tuesday. Now, real quick before you get started, let's go ahead and look at page 193. So go ahead and turn in your book to page 193 so that you know what you're doing on these problems. So page 193. Let's look at the first four. The first four says determine whether each sequence is an arithmetic sequence, right? Yes or no. So basically you're doing those like we did the very start of the lesson. That was when you said yes or no if it was an arithmetic sequence. Now notice it says to explain, okay? When it says to explain, what you're going to do is tell me what the common difference is, okay? So that's how you explain, yep. So you put like difference is 4 or D equals 4
If it's no,
or
then
D.
just
If
leave
it's
it.
no, then you would just put no common difference. Now on 12 through 17 it says find the next 3 terms. So that you're just going to go ahead and write the next 3 terms in the sequence. On 18 through 21, write an equation for the nth term, then graph the first 5 terms in the sequence. We're going to change that. You're just going to write an equation for the nth term of the arithmetic sequence. Then you're going to find the 10th term of the sequence. So make sure you make a change in those directions. Now don't write in the book. Okay, but maybe put that on your notebook sheet of paper. So 18 through 21, you're going to find a term just like we did in class. And then remember, just like we did in class, you're going to have an add-on question. Find the 10th term. Now, this is going to be due Tuesday. Now, on Wednesday, we have ITBS. And you guys will take that during this class period in here. You guys will actually be in Mrs. Osmar's room.
So we
Okay.
don't come.
So yep, so you guys won't, that'll be Tuesday, I think, and Wednesday. And then Wednesday, you've only got part of the day. So, or on Thursday, you've only got part of the day. So the other part of the day, we're gonna go ahead and,
Our papers,
we'll talk about Tuesday. So we'll talk more about that on Tuesday, but you have the rest of the
On
time to go
18
ahead.
through 21, what do we do then? We just do the sequence and then?
On 18 through 21, you write the sequence and then you find the nth term.
So what if it's no?